All right, so what we're talking about today is section 4.1, which is graphing polynomial functions. There's a lot of terms and things you have to be able to do with this. The ones that we're going to focus on today is we're going to learn about end behavior. We're going to learn about the degree. We're not really going to talk about local max or local min, not multiplicity. We will talk about whether it's odd or even, and we will begin graphing. We will not do super technical graphing, but we will begin graphing, and then we'll also try it in our graphing calculator. All right, so a polynomial function is a function that's a monomial or a sum of monomials. So this is pretty funky looking, but really it's just something that's like this. F of x equals 3x to the fifth plus 2x to the fourth. And you see how that keeps minusing 1 on the exponents? That's saying that you're minusing 1 on the exponents. Okay? That's all a polynomial function is. We could graph things up to the 10th power. Most of the ones we will be doing is from the 3rd to the 5th power. Okay? The degree of a polynomial, it's the value of the largest exponent. So this problem here is degree 5, because that's my largest exponent. Okay, so when we have something in degree 0, it would just be y equals 1, because anything raised to the 0 power is just 1, and so it looks like this. So when you have y equals 1, it's a horizontal line that just lies on top. Well, it doesn't go there because that's not 1. It's a horizontal line that passes through point 1. When you have a value of exponent of just 1, this is a linear graph, which we've done, which just goes up 1 and over 1. A quadratic is x squared. And remember that those are your u's. And then we have cubics. And cubits also pass through the origin. They kind of have a little turn. And then we have quartics. Which also pass through the vertex. Okay, but a cortex is going to be a little different because you can't see it, but it actually turns a couple times. Okay, what happens with the quartic is that it has 4 turns, 1, 2, 3, 4. The parent one you can't see. A cubic has 3 turns, 1, 2, 3. So depending on the degree, that's how many turns we have. So a 5th power is going to go up, that's 1, down, that's 2, up, that's 3, down, that's 4, up, that's 5. So it has, because it's degree 5, it has 5 changes. There's 1, 2, 3, 4, 5. So it goes 5 different directions. So any graph we have, whatever the exponent is, that tells you how many times you go up and down. Okay, the next thing we're talking about is end behavior. And end behavior can be a little tricky, but just because the notation is funny. But really, this is just saying, where does y go when x goes to the right? That's what that says. where does y go when x goes to the right? And this one says, where does y go when x goes to the left? So it kind of has funny notation, but that's all it's asking is, when I'm going to the right, does my arrow either go up or does my arrow go down? And if I'm going to the left, does my arrow go up or does my arrow go down? If your end behavior goes up, that's a positive infinity. That's what this little symbol is. It's infinity. And that's why this is to the right, because it's positive infinity. I go to the positive side, which is to the right. If it ever goes down, well, negative numbers are down, so it's negative infinity. And that's just why over here, when I went to the left, it was negative infinity. Okay? So this again says, where does y go when x goes to the right? Where does y go when x goes to the left? All right, so we're going to do a couple, and you're going to see, and once we do some, that might make it a little more understandable. So you're always going to have this, f of x goes somewhere as x goes to the right, and f of x goes somewhere as x goes to the left. You're always going to have to write that, so it's good if you just get used to that now. So looking at this graph, number one, it's a little out of focus. Let's first of all see the degree. This goes 1, 2, 3, 4. So this is the 4th degree, or it's x to the 4th. Now, as I go to the right, this arrow goes down. And going down is a negative infinity. As I go to the left, on the left side, it also goes down. So this also is a negative infinity. All right, so why don't you guys try this one? F of x goes somewhere as x goes to the right, and f of x goes somewhere as x goes to the left. So as I go to the right, this arrow points up. So since my right arrow points up, it's positive infinity. When I go to the left, my left arrow points down, and so this is negative infinity. Now let's look at the degree. How many times does it change? It goes once, twice. You see this kind of hump? It goes up there. That's 3, 4, and then 5. So this is an x to the 5th graph. All right, number 3, same thing. F of x goes somewhere as x goes to the right, and f of x goes somewhere as x goes to the left. And maybe I'm thinking about this now, maybe we should write this blank so you know that that's what you're always trying to find. Everything else stays the same, you're just trying to find where that is. So see if you can answer those. So as it goes to the right, my right arrow points up, so it's positive infinity. And as it goes to the left, my left arrow also points up, so this one's also positive infinity. Okay, so now what we're going to do is I need you to copy this table, and then we're going to talk about when functions are odd and even, what they do, and then we'll do a couple more problems. So on the left side of your notes, go ahead and copy this table down. All right, so what you should notice is what happens with odd and even. Well, let's look at our graphs. This is an odd graph. I had one arrow going up, one arrow going down. Here's another odd graph. I had one arrow going up and one arrow going down. And here's another odd graph, the 5th, one up and one down. So that should tell you that when you have an odd function, your arrows go opposite ways. You'll have one going up and one going down. Okay? So they go opposite ways. Now let's look at our even functions. This is an even function. They both pointed up. This is an even function. They both pointed up. Here, down here, we didn't say it, but this was an x squared. That's an even function, and they also both point up. Here's another even function over here, and those also point up, point down. They go in the same direction. So when you have even functions, these are going to go in the same direction. They're either both going to go up or they're both going to go down. So let's start with an even function. An even positive function, if it's positive x squared, they're both going to go up. If it's positive x to the fourth, I'm going to start going up, and I'm going to end going up. If it's positive x to the sixth, same idea. 1, 2, 3, 4, 5, 6. The exponent tells you, or the positive or negative tells you where you end. So if it's positive, it ends going up. But even functions end the same way. So this one's a negative, and so they are both going to have to go down. And again, the positive or negative is which way you face at the end. So on the right, where do you face? Okay? So positive and negative, it's where you face on the right. Which direction is the arrow facing on the right? So if this is a negative x to the fourth, 1, 2, 3, 4. Negative x to the sixth, 1, 2, 3, 4, 5, 6. Okay? So again, if they're even functions, they face the same way. If it's a positive even function, they both go up. If it's a negative even function, they both go down. Now, when you talk about odd functions, they go opposite ways. One goes up, one goes down. So if I have x to the third and it's positive, it ends going up. So it's where it ends, it has to go up. X to the fifth, same idea. 1, 2, 3, 4, 5. It ends going up. If I have an odd function that's negative, it ends pointing down. Because this is what matters. It's where it ends, determines the positive or negative. And so negative x to the fifth, 1, 2, 3, 4, 5. It ends going down. So knowing this will help us draw rough sketches, and it'll also help you understand end behavior. For even functions, they're either both positive infinities or they're both negative infinities. And this is where the y goes. For an odd function, as I go to the right, it's a positive infinity, and as I go to the left, it would be a negative infinity. And for this one, as you go to the right, it's a negative infinity and a positive. So if you notice, when they're even, they're going to be the same sign. When they're odd, they're going to be the different signs. All right, so we're going to go ahead and graph these. Now, I'm not going to be a real stickler on the graph. We're just going to kind of draw a rough sketch, and then we're going to go from there. And if we need a real technical one, we could either draw a table or you could plug it in the calculator. So go ahead and copy those down, and then let's talk about some things we know. All right, so the first thing you guys should notice is that this is an odd, so it's going to have 3 humps because it's a degree 3. The other thing that I really want you to notice right now is this. Remember that last number? That last number always tells you where you cross your x-axis or your y-axis. I don't care where anything else is now, and we'll see how accurate we are or not accurate. I just want to make sure that you have your curve going through here. And so it's a rough sketch. I know I need to have 3 humps, and it needs to end going up. So maybe it's 1, 2, 3. I just want to make sure you have it crossing the y-axis there. And so now, if I describe my end behavior, where does y go as x goes to the right? And if you look at this graph, as I went to the right, it goes up, and up is what kind of infinity? That's right, it's a positive infinity. And then where does y go as x goes to the left? Forgot my arrow here. And as I go to the left, my left arrow faces down, so it's negative infinity. So now let's graph this in the calculator to see how close or how off we were. We should have the humps right. The only thing we might have wrong is what the curve looks like. So let's plug this in. X to the third plus x squared minus 4x plus 2. And again, for our rough sketches, when I'm looking at a rough sketch, I'm going to be looking for your humps, your direction, and where it crosses the y-axis. And there it is. And so our hump had touched over here on the right, but that's okay. Do we have 1, 2, 3? Like it has 1, 2, 3? That's what matters to me. Okay, so I'd like you to try number 4. I'd like you to draw a rough sketch of it by knowing how many humps, which direction, and where it crosses the y-axis. And then I'd like you to determine, excuse me, I'd like you to determine your end behavior. Okay, so I should know that it crosses at -3. I'm going to put that -3 in the middle of my humps this time, and it goes down. So I'm going to say maybe it goes 1, 2, 3, 4. Doesn't matter where it touches. Right now, we're going to learn how to find that eventually, but right now we're just getting the direction. They both go down, and it crosses at -3. And so where does my y go as I go to the right? And where does my y go as I go to the left? And as I go to the right, it goes down, so it's a negative infinity. And as I go to the left, it also goes down, so it's a negative infinity. And then we could also graph our points. Let's see what this looks like. Maybe we got closer this time. Negative x to the 4th minus x to the 3rd plus 2x squared minus x minus 3. And so it didn't go back up as high, but we still have the 4 curves. 1, 2, that's a little one right there, 3, 4. Okay, so again, when we're graphing this, I'm not asking for it to be super specific. We will learn how to make them more specific in future notes. I just really want you to practice knowing your direction, where it crosses the y-axis, and your end behavior. So remember, if you have an even functions will end up going the same way. Odd functions will go opposite ways. And then you could tell what the degree is, and that tells you how many humps or how many different directions you go.